Hey guys, the second half of this unit we're going to focus on aquatic biodiversity. So we're going to explore aquatic life zones, and then we'll start looking at human activities in terms of how they are causing a decline in aquatic biodiversity. Like terrestrial ecosystems, aquatic life zones have limiting factors, right? Salinity, for example, determines the distribution of many aquatic organisms. Therefore, we have, of course, saltwater or marine ecosystems and freshwater. There's, of course, additional limiting factors. They include dissolved oxygen, sunlight, and nutrients. We're going to focus on the marine organisms today and the marine aquatic life zones. We're going to look at the ocean. The ocean is broken down into two major life zones, and they're distinguished from one another based on their proximity to land. So we have the coastal zone, which extends from the high tide mark all the way to the edge of the continental shelf, where the depth sort of drops off precipitously. And of course, we have the open sea. So starting with the coastal zone, this is sort of where the magic happens. Coastal zones are the most productive areas of the ocean because they have ample supplies of sunlight and plant nutrients that flow off the land. Furthermore, warm water, in conjunction with wind and ocean currents, increase the productivity by sort of moving everything around. So being the most productive portions of the oceans, this is where our major fisheries are found. While the coastal zones only make up less than 10% of the ocean, it accounts for 90% of all marine species. And of course, it is the site of the most large or the largest commercial fisheries. Moving out to sea, we have, of course, the open sea. And the open sea is marked by a sharp increase in water depth at the edge of the continental shelf. The open sea is divided into three vertical zones. This zonation is based off of sunlight penetration. The uppermost layer is what we call the Euphodic Zone. That's rich in light. The Euphodic Zone is brightly lit, where drifting phytoplankton carry out about 40% of the world's photosynthetic activity. Since photosynthesis is a dominant process happening in the Euphodic zone, we're going to have relatively low carbon dioxide levels in the Euphodic zone, but very high dissolved oxygen levels. In the open sea, there's very little nutrients since it's not adjacent to the land. You guys may recall our discussions on net primary productivity, where we described the oceans as having the most producers on planet Earth, yet its NPP is quite low. In other words, it's often classified almost biologically as a desert. Despite the fact that there's an enormous amount of producers in the Euphodic zone and the coastal zone, the ocean is so vast that the concentration of life is not there. As we go deeper from the Euphodic zone, we enter into the Bathol Zone, and this is an area where sunlight no longer penetrates. It's sort of a twilight zone, so consequently, we don't have photosynthesis happening in this layer. This layer is consistent of oftentimes smaller fish that migrate to the surface at nighttime, especially to avoid predation. Going deeper, we enter into the depths of the ocean in the abyssal zone. The abyssal zone is the dark and very cold layer of the open sea. No sunlight exists here. There's going to be very little dissolved oxygen as photosynthesis is not taking place. Carbon dioxide levels will be quite high because respiration still happens, decomposition happens, and carbon dioxide is a product of those activities. It is high in nutrients. Unlike the upper Euphodic zone, this is where all the organisms come to die. This is the graveyard. This is what makes the bottom of the ocean the largest carbon sink. So all of that phytoplankton and organisms that die fall to the bottom of the abyssal zone, and we refer to that as marine snow. These are showers of dead and decaying organisms drifting from above. On the abyssal zone, we often have deposit feeders like worms that take in mud into their guts and extract nutrients. Other filter feeders include mollusks and sponges that can be found here. You'll notice that we also have a temperature zone. This is what we call the thermocline. It's the boundary where we go from warm surface water to cold deep water. Notice how it roughly coincides with the interface between the Euphodic zone and the Bathol zone, where sunlight no longer penetrates. Of course, the depth of the Euphodic zone does vary, and it varies based on water clarity or turbidity. How murky is it? Is there a lot of sediment? Is there a lot of phytoplankton? How deep can sunlight actually penetrate? So we're going to be exploring the ocean in terms of protecting aquatic biodiversity, because it turns out that humans are getting very good at harvesting fish and other aquatic life from it. Stay tuned for our next video.